Rational zeros. Now the rational theorems here, the rational zeros theorem will give us all of the possible rational zeros that could be for any given polynomial equation. And the main part is this here, plus or minus p over q, where p is the factors of the constant term and q is the factors of the leading coefficient. Our rational zeros are plus or minus p over q, where p is the factors of the constant term and q is the factors of the leading coefficient, the number in front of the variable with the biggest exponent. So, if we use that for this problem here, I'll take it. So, plus or minus p over q. First, we need to find the factors of p, the constant term, and then we need to find the factors of q, the leading coefficient. So, what would our p value be here? Our constant term would be 20. So, we're wanting to find the factors of 20. We're wanting to find the numbers that multiply together to give us 20. Well, we will have 1 and 20. We will also have 2 and 10, 4 and 5. So all the numbers that multiply together to give us 20 is 1 and 20, 2 and 10, 4 and 5. Questions on how we found this so far? Q is the factors of the leading coefficient, so the factors of the number in front of the variable with the biggest exponent. What would that number be? 1. So we need to find the factors of 1. 1. Okay? Questions on how we found the values for P and Q? Do we feel comfortable finding the values of P and Q? Now what we're going to do is we're going to take each value of P and divide it by each value of Q. I always start this one at a time, so I'm going to start with the first value of Q and divide every P by it. And we have to put plus or minus in front. So our first one would be 1 divided by 1, which is 1. Yes? 2 divided by 1. 4 divided by 1. 5 divided by 1. 10 divided by 1. And lastly, 20 divided by 1 is 20. So we take each one of these here and divide it by 1. And we get this here. We get these 1, 2, 5, 4, 5, 10, 20. If there was another value of Q, we would then divide each value of P by that value. And if there's any repeated numbers, any repeated values that we find in this P over Q, we do not list them twice. Because again, it's listing all of the possible zeros. If it's already listed once, we don't need it twice. But here, we don't have any other values of Q. So our possible rational zeros are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and plus or minus 20. Questions on how we found these? All right. Now, the pure math way to do this next is synthetic division. So the numbers going across the top would be our coefficients for this equation, 1 for x cubed, negative 8 for x squared, 11 for x, and 20 for our constant term. We'd bring the 1 down. Well, the number that goes in the cubby, well, we have several options, but if I were y'all, I would start with 1. Don't write this out because this is probably going to get a little tedious, because is there any guarantee that 1's going to give us a remainder of 0? No, because if it does give us a remainder of 0, it means it is a solution. If it gives us something other than 0, it's not a solution. 1 times 1 is 1. We would add straight down. Negative 8 plus 1 is negative 7. 1 times negative 7 is negative 7. We would add negative 11, or 11 plus negative 7 is 4. 1 times 4 is 4. 20 plus 4 is, so here the remainder is, okay? So that didn't work. What can we do next? Because it is positive and negative, isn't it? So we could do it with negative 1. If that works, it's a solution. If it doesn't, we mark it out and move on to 2. If it works, it's a solution. If it doesn't, we go to negative 2. 4, negative 4, 5, negative 5, 10, negative 10, 20, negative 20. And keep checking, and if it does give us a 0, we mark it down as one of our solutions, and then we move on to the next value. And since it is a cubic, we said that we need n minus 2 solutions at minimum, where n is the degree. So since the degree is 3, 3 minus 2 is 1. So it's telling us we need, at minimum, 1 solution before we can use our properties of quadratics to solve. You know what? Before we start graphing this or graph this, let's try negative 1. Negative 1 times 1 is negative 1. Negative 8 plus negative 1 is negative 9. Now we're going to multiply again. Negative 1 times negative 9 is positive 9. 11 plus 9 is 20. Negative 1 times 20 is, which is indeed 0. Questions on this so far? So all we know for sure is negative 1 works, yes? I can tell you this, 1's not going to work on the next one. So if I did synthetic division again, since positive 1 did not work on the first set of synthetic division, it's not going to work here. If it's not a solution at the start, it's not going to be at any of the steps. So 1's already gone. Now we could try negative 1 again. We have seen repeated solutions. But we also have a lot of other solutions to try also, yes? But up to this point, there's been a way that we've been checking or finding solutions, yes? And now we've been doing that with graphing it, yes? Go on and graph this. Y equals, up at the top. X cubed minus 8x squared plus 11x plus 20. Once you get it typed in, hit graph. And we get something that looks like this here, yes? Well, it is intersecting at negative 1, isn't it? We can also go second table. And again, when we look at the table, we look at the graph. When we're looking at the table, we're looking for what value of x makes the y value be what? 0, yes? And at negative 1, the y value is indeed 0, isn't it? Any other values that give us 0? 4 and 5, yes? So we know the other, or 2 more of the solutions are 4 and 5. So we know x should equal negative 1, 4, and 5, yes? That's it. Those are the 3 solutions. Those are the 3 places across the x-axis. Now, if I wanted to, I could try 4 with synthetic division. 4 times 1 is 4. Negative 9 plus 4 is negative 5. 4 times negative 5 is negative 20, and 20 plus negative 20 is 0. If I plug the variables back in, our 0 is our remainder. 5, negative 5 is our term without x. 1 is our term with x. Minus our last equation is x minus 5 equals 0. To solve for x, we would add 5 to both sides because negative 5 plus 5 is 0. 0 plus 5 is 5. Well, it's just telling me that my third value is 5. But the graphing calculator already gave that to us. Questions on this here? We good? You able to graph it? Were you able to get it graphed? Graph. To look at the table or graph. Yeah. So once we get it typed in, hit graph. Okay. Well, let's look at the next one. Because the big thing with all of these here with solving is, I would say, being comfortable with graphing these is going to be very helpful in solving. Now, we are going to graph this here, but I do want to find the rational zeros first. So P, the values of P are going to be the factors of the constant term. And in our case, it's going to be the factors of 24. We're not going to worry so much about the negative because, again, when we plug it into the plus or minus, each one of them is going to be positive, negative. It's going to take care of any sign issues that we might have. Now, 24, we have 1 and 24. We also have 2 and 12. 3 and 8. 4 and 6. So there's a good number of factors for 24. 1 and 24, so 1, 2, 3, 4, 6, 8, 12, 24. Q is the factors of the leading coefficient, the number in front of our variable with the biggest exponent. Well, the number in front of x cubed is 1. We don't write it, but it's understood to be 1. So what we're going to do is divide all those values of P by our first and only value of Q, which is, so we'd first off have 1 divided by 1, 1 over 1, which is 1. We do the same thing with 4, 8, 6, 8, 12, and questions on this here. Do we feel comfortable getting this? Because I know I skipped a whole bunch of steps there, but really 1 divided by 1, 2 divided by 1, 3 over 1, 4 over 1, 5 over 1, 6 over 1, going through with this here. Now, if you need, there's nothing wrong with grabbing, especially the yellow calculator. It should be easier on that 30XS. Hit that fraction button, do P over Q values for all of them. Because you can plug them in, it'll reduce them fine. We have that there, but if there is a rational solution for this here, it's going to be listed here. Or we can stick it in the graphing calculator. X cubed plus x squared minus 14x minus 24.
My thing won't let me go to graph.
Let's see what it says.
Go to what? And press graph.
Well,
So I was messing with it.
we need to type the equation in. Graph.
Okay, now it wants to work.
Hit zoom 6 to fix the window. Now it's going negative 10 to 10. Okay, don't like that it's doing that. There we go. X cubed plus x squared minus 14x. Yeah, because it was going to want to put parentheses around. Yes. Okay. Hit y equals. Let's see here. Oh. See next to the 24 how there's that little spot?
Yeah.
It's looking for an exponent. So put the cursor up there. So use the left arrow. So it's cursor over. Do you see how it's hovering up there? Delete. Graph. A graph it this time?
I don't change the setting on my calculator because whenever I enter it, just says
So plot one's turned on.
Oh, no. Okay.
Because it's trying to plot its points. Plots are points. So there are no plots points. You don't have any values in there, so it's trying to plot something that doesn't exist. All right, guys, did we get this here? We get a graph that looks like this? Now, if we want to look, we can go second graph and look at the table. And again, we're looking for values of x that make the y value be 0. Well, we have a few, don't we? Negative 3, negative 2, and 4. Interestingly enough, this type of equation, cubics, have 3 solutions. So higher degree polynomial equations of degree 3 will have 3 solutions. Well, how many solutions do we have? 3. If a solution is repeated, we count each time it's repeated as a different solution towards the whole. So for a cubic, we could have x equals 2, 2, and 2. We could have it repeated 3 times. Questions on this here? We feel good with these so far? Yes? We're going to skip this and we're going to go to this one. 10x to the fourth minus 11x cubed minus 42x squared plus 7x plus 12. Realistically, first place we probably are going to go is going to just graph it, yes? No, why not? 10x to the fourth minus 11x cubed minus 42x squared plus 7x plus 12. Once we get the whole thing in, we hit what? Graph. So we see here it does cross the x-axis 4 times, just like we expect it should. So that means we do have 4 solutions. And it looks like they all should be between -2 and 3, yes? So let's look at the table, see if we can get some more precise answers. And which values of x make the y value be 0? It doesn't show us any, does it? Because none of these values give us a y value of 0. So this time we're definitely going to need to find our rational zeros. Because again, we need to find at least n minus 2 where n is the degree. So since the degree is 4, we need to find at least 2 solutions to be able to find the rest. Now p is the factors of our constant term, our term without x. So we're looking for the factors of 12. So we have 1 and 12, 2 and 6, 3 and 4. Factors of q. Q is the factors of our leading coefficient, the number in front of the variable with the biggest exponent, and that number in our case is what? 10. So we do have 1 and 10, and we also have 2 and 5. Questions on how we found the factors of P and Q? And when I list them out, I always start dividing all the values of P by the first value of Q. We're going to divide everything by 1, yes? Which is just going to give us what? Plus or minus 1, 2, 3, 4, 6, and 12. Really, we just divided every P by 1. So 1 divided by 1 is 1. 2 divided by 1 is 2. 3 divided by 1 is 3. 4 divided by 1 is 4. 6 divided by 1 is 6. 12 divided by 1 is 12. Be good with the first step. Yes? Now we feel okay. Just making sure. Now we're going to move on to our next value of Q, which is 2. So the first thing we're going to do is P over Q. 1 over 2 is 1/2. 1/2 does not reduce. That's as simplified as it gets, yes? So we list it. Next one we're going to have is 2 divided by 2. What's 2 over 2? 1. It reduces. Do we have 1? I'm not going to list it twice. Next one we're going to have is 3 over 2. Does 3 over 2 reduce? Nope, and it's not listed, so we do have 3/2, yes? 4 over 2 is 2. We have it, yes? 6 over 2. 3. It's listed, yes? And lastly, 12 over 2. It's up there, yes? So the only 2 we had to list for when Q is 2 is 1/2 and 3/2. Now we're going to move on to 5 and do the exact same thing. So we're going to have 1 over 5, so we do have plus or minus 1/5. 2 over 5 doesn't reduce, so we have plus or minus 2/5. 3 over 5 is going to be plus or minus 3/5. 4 over 5 doesn't reduce, so we also have plus or minus 4/5. 6 over 5 doesn't reduce, and 12 over 5 doesn't reduce. Really, with these here, if you need that yellow calculator, just type them in. The p-value over q. 1 over 5, 2 over 5, 3 over 5, 4 over 5, 6 over 5, 12 over 5. Just type them in and see, does the calculator reduce it? If it does, and it's already listed, we don't write it again. Even if it does reduce, if it's not already listed, we're going to put it in. Are you ready for tenths? Yeah, I mean, ready or not, we have to do it. So the first one we had would be 1 over 10, which is 1/10. Next one we have would be 2/10. 2 over 10 is 1/5. We do have it. 3 over 10 doesn't reduce. It's not listed, so we do have 3/10. Our next one would be 4 over 10. 4 over 10 reduces to 2/5. 6 over 10 is 3/5. And 12 over 10 is 6/5. So 4/5, or 4/10, 6/10, and 12/10 all reduce, and they are already listed. Questions on this here? All right. Now we got to figure out which of these values work, yes? Yes. Which ones do we know that do not work for sure? When we look at these here, 1, 2, 3, 4, 6, 12, positive and negative values. Wait a minute. 1, 2, 3, 4, 6, 12. None of those have a y value of So those aren't going to work. If we look at their negatives, -1, -2, -4, -6, and -12, that's 12 answer choices that we don't even have to check. We don't even have to figure out. Those are all gone. Because if they were solutions, the graphing calculator would have told me pretty quickly, pretty easily. And especially we would have seen it here, yes? Now we have a lot of fractional answers to check because those didn't show up in the table. Okay? All right. I want you to hit second trace, second trace, second calculate. So we should get a list that looks something like this here, yes? Second trace. So second's blue, trace is at the top. Yep. So we all got something that looks like this here, yes? What's that first option we have? Value. Hit enter, select it. Now it has x equals. Now this will let us put in values of x as long as it's inside the window. And the window for us here in the default window is -10 to 10. So as long as that value of x we plug in is between -10 and 10, we're fine. Well, all these rational zeros that we have left to check are between those two values, yes? Well, the first one or the next one we have in our list is 1/2, yes? So put 1 divided by 2 and hit enter. So I'm going to type them in as division, numerator divided by denominator, top divided by the bottom. And when x is 1/2, the y value is what? Tells us right there. It tells you on your calculator, yes? 4.25. So is 1/2 a solution? No, because we need the y value to be what? 0. Now, up to today, really, after I did the first, second trace enter, and we saw that 1/2 didn't work, I would always hit second trace enter to type the next one in. I figured out today that we can actually just type the next one in. So I would try -1/2 next. And when x is -1/2, the y value is what? 0. So we can say -1/2 is so we've already tried 1/2, we've tried -1/2. Our next value is what? 3/2? So that's not 0. Ready? Second trace. Now the first one says value. Select it. So what this is doing is letting us plug values of x in to see what their corresponding y value is. Now the next one we're going to try is -3/2. And when x is -3/2, it tells us the y value is -5.25. So that's not a solution because we need it to be 0. Now luckily after you type, yep, so it does tell us the y value right down there. So 3/2 or 1/5 did not work. I can also try -1/5. It gives us a y value of 9.024. Doesn't work. And then our next one is +2/5. No. -2/5. 3/5. The y value is. Y'all see how we can type these in pretty quickly. Second, we can do second trace enter each time, but we really just need to do it once, and then we can just start putting zeros, those values of x in to check. So the next one is I will tell you this here, those are the only two values that work. Those are the only two rational solutions we have. We now have to use those to get it to a quadratic so we can find the rest. So our numbers across the top are going to be 10 for x to the fourth, negative 11 for x cubed, negative 42 for x squared, 7 for x, and 12. We're going to bring the 10 down and we're going to start synthetic division. Now, it doesn't matter if we use 1/2 or negative 1/2 or 3/5. We just got to pick one of them and do it first. Now, this multiplication addition step, if you need the calculator to do it, use it. Use the calculator. Negative 1/2 times 10 is negative 5. Negative 11 plus negative 5 is negative 16. Negative 1/2 times negative 16 is positive 8. Negative 42 plus 8 is negative 34. Negative 1/2 times negative 34 is positive 17. 17 plus 7 is 24. Negative 1/2 times 24 is negative 12. And 12 plus negative 12 is 0. Questions on this first synthetic division before we do it again with 3/5? Are we ready to do it with 3/5? 3/5 times 10 is going to be 6. Again, if you need the calculator to do these fractional multiplications, grab the graphing calculator or 30xs. Let it do it for you. As we have that, then we're going to add negative 16 plus 6 is negative 10. 3/5 times negative 10 is going to be negative 6. Negative 34 plus negative 6 is negative 40. 3/5 times negative 40 is negative 24. And 24 plus negative 24 is 0. Questions on this here? Now at this point here, we need to fill the variables back in. Negative 40 is our constant term, our term without x. Negative 10 is our term with x, and positive 10 is our term with x squared. Telling us the last equation we need to solve is 10x squared minus 10x minus 40. Now this equation here does have a middle term, so we can't use the square root method. So really our only two main methods are quadratic formula or completing the square. Because factoring is not going to work, it's not going to be factorable. And the main reason we know it's not factorable is because if it is factorable, it means the solutions are rational. They would have been in that list. So we need to use, I'm going to use the quadratic formula. So we're going to plug in the values of A, B, and C into their corresponding spots. So B, let's start with A. A is 10. And there's two places A shows up. On bottom and next to the 4 inside the radical. So we're plugging positive 10 in both of those spots. The next number that we have is our B term, which is negative 10. And the two places where B shows up, we're going to plug negative 10 into both of those places. And the last number we have is C, which is negative 40, and it only shows up once inside the radical. Questions on this here? Negative, negative 10. The negative and negative will make a positive, so it's positive 10. On bottom, 2 times 10 is 20. Now, the only other thing we have left to simplify at this point is everything inside the radical. So our negative 10 squared minus 4 times 10 times negative 40. Now, this point here, I would definitely negative 10 squared minus 4 times 10 times negative 40. Type all of that into the calculator. And see what we get. So we're saying that everything inside the radical should simplify down to 1,700. Now we do need to reduce the square root of 1,700. Now unfortunately the graphing or the 30xs won't do this for whatever reason. But if we did this by hand, square root of 1,700 is really, we can say 17 times 100, which is same as saying the square root of 17 times the square root of 100. Well, the square root of 100 is 10, and we can't reduce the square root of 17. Questions on this here? Well, we can say this is the final answer as long as the numbers on top do not have anything common with the number on bottom. Do 10 squared root of 17, and 20 have a common factor? Yeah, those are all divisible by 10. 10, 10, and 20 are all divisible by 10, yes? So if I divide 10 out of all 3 spots, well, 20 divided by 10 is 2. The first 10 on top, 10 divided by 10 is 1. Now, 10 square root of 17 divided by 10, well, the 10 over 10 would reduce to 1. So 1 square root of 17, or just the square root of 17. Now, there are 2 answers there because we're looking at 1 plus the square root of 17 over 2 and 1 minus the square root of 17 over 2. So those are the only other 2 answers. So there we have all 4 solutions for this here. Questions on this here? Now, it might be possible for us to get this next problem in, but I'm going to save it for tomorrow. I don't want to rush and try to drag y'all through this.